Welcome to the video on redox and electrode potentials. I just like the idea of me being a floating head, so I'll switch this nice black top. So I'm just a pair of hands and a floating head, okay? But still me. So redox and electrode potentials, balancing redox, half equation using acid and alkali conditions. We are going to do that now. Now, I'm going to show you how to do it, hopefully in an easy and simple way. Redox, just a reaction where you've got reduction and oxidation. So we're going to go through reduction, oxidation. Oxidation number is just the number of electrons gained or lost. And we'll talk about that a lot. Half equations, okay, they just show a species that's losing or gaining electrons. So normally you have a reduction half equation and an oxidation half equation. Now, what we're going to do is we're going to balance these half equations with additional waters and H pluses. And we'll do that in the next part. Now, we're also going to go over oxidizing agents. Okay, a substance that causes another substance to be oxidized and it's reduced. So if it's reduced, it's gaining electrons, which means something else must lose. Okay, so it's causing something else to lose, which means it's the oxidizing agent. Reducing agent. A reducing agent is a substance that causes another substance to be reduced, and therefore it must lose. So basically the opposite. If something loses electrons, it's the reducing agent. If something gains electrons, it's the oxidizing agent. Now, this is the process we're going to follow. Not going to go through it in detail right now. I'm going to put it to the side, okay? And we're going to go over each part one at a time. So balance the atom is having its oxidation number changed. So let's have a look at our first one. So Fe2 plus goes to Fe3 plus. So the question says, if you want to balance this half equation, this is your start of your half equation, and you'll be given this, and then you'll have to expect it to balance it. Balance the atom that's having its oxidation number changed. Well, the oxidation number of this one is +2. Remember, it's +2, not 2 plus. You need to reverse that, +2. And you should have done a redox before you do this video. So that's +2, and that's +3. So that's having its oxidation number changed, so we need to balance that atom. That's the first thing you do. And it's already balanced, so that's fine. Okay, so then add water to balance the oxygens, no oxygens. Add hydrogen ions if required. There's none in there, so I don't need it. Balance the charge, adding electrons to the most positive side. So if you look at the most positive side, let's get a pen here. Okay, Fe2 plus goes to Fe3 plus. Okay, this is the most positive side. Okay, and I have to add electrons so that both sides balance. So that is a 2 plus, so I have to add a negative electron to this, right? Okay, so that's plus E minus. Okay, so plus E minus. Now, if that's the case, we then go on to the next one. Okay, and we've got I2 going to 2I minus. So again, balance the atom that's having its oxidation number changed. Well, this is 0 because it's an element, and this is -1. You see here -1 and 0. So that's having its oxidation number changed, so I need to balance it. Okay, and if I'm balancing it, that means, well, in this case, it's already balanced. It's already done. Okay. So I've got 2 I's and 2 I's there. Then it says, again, none of the oxygens, none of the hydrogens, none of the electrons. Okay, none of the hydrogens, and then add electrons to the most positive side. The most positive side, okay, so if we look at this, okay, that means we've got that to that, I2 to 2 minus, okay, that means that must have gained 2 minuses. And if it's gained 2 minuses, oops, do apologise. Let's put that back. Okay. So if I2 to 2 minus, that means I must have 2 electrons on that side. So that basically means that's balanced and that's balanced. And they're the most simple ones. So you're gaining electrons in this one. So this is going to be our reduction. Okay, and you're losing electrons in the other one. So this one is going to be our oxidation. Okay, so that is our reduction and oxidation, losing and gaining of electrons. So our next set of equations to do is chromate and manganate. And you can see here we've already put our oxidation numbers in here. And we can see from this 7 times -2 is -14. To get to -2, we have to do -14 plus 12. 12 is for this, or plus 12 is this. There's 2 of them, so 12 divided by 2 is plus 6. If we then go for the next one, try and do it yourself again. This is minus. There's 4 times minus 2 for oxygen, which is minus 8, which means to get a minus overall, the manganate must be plus 7. Okay, so it must be plus 7. Now that one's pretty easy as well because it's plus 2, just it's the same as the charge. Right, okay. So if we carry on doing this now, and we do exactly what it says over there. Okay, balance the atom which is having its oxidation number changed. Well, the atom that's having its oxidation number changed is the chromium, and it's already balanced in that equation. And the oxidation number is being changed for the manganate, which is already balanced. Okay, add water to balance the oxygens if required. Well, there's 7 oxygens here, so I need to balance that. So what I do is I go over to this side, and I will do plus, and I'm going to do the 7 oxygens. So each water has 1 oxygen in, so I'm going to put 7 waters in. If I then go and do exactly the same thing down here, manganate, there's 4 oxygens, so I'm going to need to add, and let's do this right here, I'm going to need to add 4, okay, and 4 waters, okay, so 4 waters on that side. If that is the case, I then go to my next part, okay, really, really important, is add the hydrogen ions if required, and the hydrogen ions are to balance the hydrogens you've added in the water. So that means 7 times 2 for the hydrogen is 14. So what I need to do is go over this side and I have to add 14H+. So we've got 14H+, get myself out of the way, 14H+, plus that, okay. And then we go down to here and we'll look at it and go, right, manganate, and then 2, right, okay, how many hydrogens we've got? We've got 4 times 2, which is 8. Okay, so if we go down here, and we're going to put our plus in, like that, that is going to be 8H+. Okay, so 8H+. So we've got 8H+ on this side. Now all we have to do, I'll get out of the way so you can see. Okay, all we're going to have to do is look at both of these and say, which is the most positive side? Balance the charges, adding electrons to the most positive side. So the most positive side on this one, remember that is 2 minus, plus the 14. So 2 minus plus the 14. So overall, that means that this side, okay, so that side only is 2 minus plus 14. So that's 12 plus. Okay, that's 12 plus 2 minus plus the 14. And then on this side, okay, we have got 2 times 3 plus, which is 6 plus. And so overall, this is 6 plus. Okay, now if that is the case, get away again. Okay, the most positive side is that side. I need to make it so it's equal to this number. So I have to add 6 minuses. All right, so I'm just going to quickly add 6 minuses. So 6E minus, okay, and then I am done. Okay, and that's my balanced half equation. Think about it, what do you do on this side now? So again, if I take the purple, I get down here, so I'll get out of the way. Okay, and we've got here, and on this side, 8H pluses, and so, well, that means on this side, okay, because you have got the minus plus, that means 7 plus. Okay, makes sense? Okay, and then on this side, let's do that. On this side, 2 plus. Difference between that and that is 5. The most positive side is that side. The most positive side is that, so I have to add 5 electrons. Okay, so that means we have balanced 2 half equations. Now, why do I do these 2 half equations? You're going to have to memorize these. Okay, so now I wouldn't recommend totally memorizing them. I'd recommend that you know these parts, and then you just work out the rest. Okay, and that's all you do. So these are probably 2 of the most important half equations in your entire course. So make sure you know how to balance them with acid on both occasions. So balancing acidic half equations, okay, we're just going to do a few of them, and we're going to do them a bit more quickly now because we did them slowly before. So basically when you look at this, you've got to follow this totally, and that's all we're going to do. Okay, and all we're going to do is write straight away. So SO3 2 minus 3 times minus 2 is minus 6. That means we've got plus 4, which means basically we have got a +4 here. Now, I'll go through that again. 3 times -2, because -2 is the oxidation number of oxygen, is -6. 2 are there, so we're left with -4. So therefore, the sulfur must be +4. We'll then go to this, okay, and you do the same thing, and you find out that this is +6. Okay, so that's +6. So we've done +6, and we know that that's changing its oxidation number, so therefore we've got to balance it. It's balanced 1 to 1. We then look at the oxygens, and we say 3 oxygens here, 4 here. Okay, well that must mean that we have to balance those oxygens, so we're going to add H2O there. So we're going to add H2O. We've added H2O, there's 2 hydrogens, and therefore we have to balance those hydrogens with acid, so that's 2H+. Okay, so from that, we know it's neutral that side. Okay, 2- plus 2H+ is neutral, and we've got 2- on this side. Okay, so that's the more positive side, so I have to add electrons to that side. That side is 2-, this side is neutral. So it's more positive, so I have to add the electrons to make it match. Okay, so to make it match. So there's your 2E-. Okay, and that's your first one done. Okay, we'll then go to the next one, manganate. We already know the manganate from when we did it before, and that is +7. Okay, we then go to this one, which is +2. So this is a good reminder of what you did before. Okay, and we're just going to write that out really, really quickly this time. Okay, go through it one more time. So that's balanced 1 to 1. Okay, we've got 4 oxygens there, so it would be 4H2O there. Okay, and I don't apologise for doing it again. This is one of the most important ones. Okay, and then you've got 4 times 2, which is 8H+ there. So we'll add 8H+. We're balancing the hydrogens. And then this side, okay, is +7, and this side is +2, difference of 5. So we've got to add 5 electrons there. Right, okay, we then go to the next one, H2O2. This is a bit of a weird one in oxidation numbers. Remember, it's 1, 2, 3 for Hockel. Okay, 1, 2, 3 for Hockel. So it basically means everything in group 1, 2, 3, that's first, that's the priority. And then F, then H. Oh, so that means H comes next, which means that the element you come to first has a fixed oxidation number. And the fixed oxidation number for hydrogen is +1. Okay, so that is +1. Okay, which means that the oxygens, because there's 2 +1s, the oxygens must be a bit weird and be -1. I even wanted to write -2 there because it normally is -2, but it's -1. Okay, so that's -1 there. This is an element, which means it will be 0. And if that's the case, all you need to do next is go to the waters. 2 oxygens, no water needed. Okay, and then we go to hydrogens. Okay, no hydrogens, 2 hydrogens. Okay, we need to add some hydrogens on this side. Okay, so that would be +2H+. Okay, so we've added it on this side, and then we go to balance the charges, adding electrons to the most positive side. So the most positive side, this is 2+. Okay, this is going to be neutral, so there's nothing. Try and ignore that bit there. There's nothing here, it's just neutral. And then this is 2+. Okay, that means this is the most positive side, so I have to add the electrons to the most positive side. Okay, right, we then go to the next one. Slightly different, it is the hydrogen peroxide again. We know the oxidation numbers, +1, -1. And then we go to this one, and we can go to the water, and we know that that's +1 and that's -2. So the one that's having its oxidation number, I'll write these again here, just to make it clear, okay, is the oxygen. The oxygen is changing there. That means we have to balance the oxygen because the oxidation number is changing, so that's a -1 going to -2. Right, okay, there's only 1 oxygen there, so I'm going to need to balance it. Now, if I'm balancing it here, I just put 2. That balances the oxygen, but I've got 4 hydrogens here, 2 hydrogens here, so I have to balance the hydrogens. And that's +2H+. Okay, so I've balanced the hydrogens now, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so we've got that. The most positive side, this is 2+. This is 0, this is 2+. This is the most positive side, so I have to bring it down to 0 because 0 is the other side, and that's +2 electrons. Right, so that's 4 worked through quite quickly. So what we're going to do is move from there and look at the title. The title's going to change. Okay, balancing alkaline. This is not very often asked, but we're going to change these into alkaline ones now. So if we change these into alkaline ones, you can see there's just an extra one at the bottom. If in alkaline conditions, add as many OH minuses to both sides as H's, and then cancel out the extra waters. Now, what does that mean? So we're going to change our ones that we've got here. So we don't need these anymore, so I'm going to try and get rid of these. Okay, because we've done all that. Superb. Right, so we've done all that. Just trying to clean up this little bit here. So there we go. Okay, and that's all done. So we've got our equations. It says if in alkaline conditions, we're doing alkaline right now, okay, we need to add as much alkaline as there is H pluses. So there's H pluses, there's 2 of those. So I'm going to add, I'm going to do it in purple here, okay, I'm going to add 2 OH minus there. Now, here's the important thing. I have to add it to both sides. If I'm adding it, I add it to both sides, okay? So on the top one, I'm going to have to add 2 OH minus. So 2 OH minus. And I'm going to have to add 2 OH minus to this. Now, when you add OH minus to H plus, hopefully you're getting it. What do you make? Well, you make water. So if I added 2 OH minuses to 2 H pluses, I would make water. Okay, so I would make my water there. Now, if that's the case, I then cancel out the waters. There's 2 waters here and 1 water here. Well, I can't have water on both sides, so that water will cancel out 1 water on that side. So what I do is I cancel out one of the waters. I cancel out this water here. And I have turned it from an acidic half equation to an alkaline half equation. And if you want to check it still works, you just check that it balances on both sides. So 2 minuses plus 2 minuses is minus 4, sorry. So that's minus 4 on that side. Now, is it minus 4 on that side? Minus 2, 2 minuses. It's 4 minus on that side. I'm great. Thank you very much. Superb. Right. Okay, so we do the same one. Manganate, we want to do the same thing. Again, if that's the case, you've got H plus on this side, so I'm going to add 8 OH minuses. 8 OH minuses to 8 H pluses makes, okay, 8 H2O, okay? 8 H2O. Okay, and that's what we've got. Now, if that's the case, we have to add the 8 OH minuses on the other side. So let's get that in the right place. 8 OH minus. Okay. Then we have to cancel out the waters. 4 there, 8 there. Well, I can't have them on both sides. Okay. So I'm going to cancel out my 4. Okay, and I'm going to cancel the 8. And that leaves behind 4 H2O there. Okay, and again, you look at the charges. There's 6 minuses on that side. Okay, 2 plus 8. But yeah, all works. It's all good. Right, okay, we'll do the next one, and we'll do it a little bit quicker this time. Okay, this time we've got the H pluses. Let's add 2 OH minuses. That turns into 2 H2O. Okay, so that's 2 H2O. And then we have to add the 2 OHs on this side. All right, so this has to have 2 OH minuses. If that's 2 OH minuses, let's see, have we got any waters that side? Have we got any waters? No, so we don't need to do the third bit where the water is there. Don't need to cancel. So this, if you look here, balancing again, 2 minuses, 2 minuses, it works and it should all work perfectly. Last one, okay? Last one, 2 OH minus, 2 H pluses, so I'm going to add 2 OH minuses, which makes me into 2 H2O. Okay, and then I added 2 OH minuses at that side, so I've got to add on the other side as well. Okay, then, and here's the important thing, I've got 2 H2O this side, and I've got 2 H2O that side. Okay, I've got to cancel both. So, cancelling both, getting rid of that, and unfortunately I cannot rub out this H2O, so I'm just going to have to be, let's get red. Let's get a better pen. Okay, so this H2O here is gone. Okay. There you go. Absolutely gone. That is not here anymore. There you go, that's clear. Okay, right, and that is how you do alkaline half equations. Now, when I post this video, I may post a few examples in the comments. Feel free to have a go at those as well. Practice is always perfect. Okay, so let's combine these half equations together. That's the main thing you do to do titrations as well. So there's links forward to titrations. Firstly, work out the correct half equations. Okay, we've got these ones, okay, and we've got they're all balanced apart from the electrons. So there you go. Electrons have to be the same number. So you're going to have to balance this to make sure the electrons are the same number, and we'll do that in subsequent examples. Okay, and then you see that, right, we put them together. So the electrons have to be the same before you do that. So you're going to have to do some work there sometimes. If you add them together, the electrons are there, and then you cancel out the electrons on both sides. All right, so what we do here, and you can see here, we can cancel the electrons. If they're the same number, we can cancel the electrons, and our final equation is this. And this can then be used to do a titration, for example. Okay, and you can check always with these whether they work or not, because the charges should balance. It's a quick and easy way of seeing whether it balances properly. You can obviously do the normal way of balancing, but the charge one tends to be good. So 2 times 2 minus is 4 minus, 1, 2, 3, 4 minus. Okay, so it balances. So if we look at the next one, iron and manganate reacting. This is the most common one you'll see. You'll see it in the exams all the time. If that's the case, we can take our half equation. So we've made our half equation. Okay, and then we can take our other half equation. So we've gone from our starters to our half equations. We then have to make sure the electrons on this match the electrons on that. So to do that, we times this one by 5. Okay, so when we times it by 5, we get the following. Okay, so we've times it by 5 to get that, and that's your normal thing that you'll do. You then add them together. So if you add them together, all I've done is taken all of this and write them down. So the Fe2 plus has been added to that side. You can see the Fe2 plus is there. The Fe3 plus has been added to the other side. And then those electrons cancel again. Okay, so the electrons cancel. And if the electrons cancel, you get this as your final equation. Now this is like a semi-hard one, you know, it's one right in the middle because you're not having to cancel waters. So we're going to do one next, where you have to cancel the waters and possibly the H pluses as well. So with that in case, let's have a look at bismuth and manganate. So bismuth or bismate, okay, this oxygen thing here reacts with this. Now if it reacts with this equation here is just the one you've had before. It's just the opposite way around. Okay, and this time the bismuth species is gaining the electrons. Now you can see there's 2 and 5 to start off with there. Now think about what do you have to do to make this number, the electrons, equal each other. Okay, well the common number here that we're looking for, the common factor, is 10. So we have to make these both 10. So we'll have to times this one by 2 and times this one by 5. And if we do that, we come up with these. Now if that's the case, you can see the electrons are both the same, which means when I combine the two together, I can cancel the electrons out. Okay, but also notice there's water on this side and water on this side, and there's H plus on this side and H plus on that side, which means everything's going to cancel. So this looks very complicated, so I'll get rid of some of it. Okay, you've combined these two half equations to make this one. So look, 2m2 plus 5BiO3 is there, 30H plus, which is here, 8H2O, and your 10 electrons from this side. So this bit is all here. Okay, and then adding all those two together, and you get that one there. Now, what's really important here is that you must cancel from this point. If you have something on one side and it's also on the other side, you have to cancel. So there's 30 H pluses on this side, 16 on that side. So 16 H pluses gets cancelled, leaving behind 14. It's 30, take away 16 is 14, and that's why you get 14 here. You cancel your electrons because they're the same number, and then your waters. So if you look at your waters, you have got 8 on one side, 8 here, and you've got 15 here. That's the bigger number, so 15 take away 8 is 7. Okay, so and it's on that side that you've got the big number, so you've got 7 waters remaining. You can then look at this and just see if it all balances, and I assure you it does. Okay, and that's a simple way, I hope, of combining these two equations and half equations together. Okay, let's do balancing redox equations. So these are when you balance equations that are redox, but you don't normally balance them like this. You balance them normally by looking at each type of element on each side, and then you make sure they're the same number of each type. With redox, you use the electrons to balance it. Okay, and if you have a look at one and it says balance the redox equation, or you look at it and it's so complicated you can't figure it out, it's usually because it's a redox equation. So the most common ones, we're going to do 2 less common ones and 2 more common ones. Okay, we go for this one here. So the first thing you have to do to balance a redox equation is, well, there are 2 ways of doing it. We're going to show you what we think is the best way, but I will discuss the other way as well if you want to try it. Okay, you take the equation and start doing the oxidation numbers. Now you find out with the oxidation numbers of these ones that this is 0, and you find out what's being reduced and what's being oxidized. So basically we have got 0 to 1 and then 0 to +1. So if that's the case, right, I'm going to do this here. That means if I go from this one and I go all the way over here and I go to here, and this is important if you're ever describing this as well, you go from here to here, 0 to -1. So basically that means gains 1e minus. Okay, so gains 1e minus. Makes sense. Okay, and then we go from here again, and this time, and I'm going to do a big one out here, just because, there we go, up, whee, all the way down here, right? Okay, so I've got that all the way down here. Now that's going from 0 to +1, so that means that is losing 1 electron. Okay, so you look for the things being reduced and oxidized. So I've looked for it, I've found the thing that's being reduced and oxidized. So if that's the case, it's balanced. Can you see the electrons are balanced? Then what you do afterwards is you go along and you check that everything else balances, because you know you've got the right number of this chlorine, because there's 2 chlorines here, the right number of electrons, and you can see 1 chlorine, 1 chlorine. So the chlorines are correct, which means I can't really change anything else, because if I change it, I'll change the electrons, and that can't be good. Okay, so all I then do is I start trying to work out everything else from that. So if you look here, there's 2 sodiums, okay, and so it would make absolute sense if I then finish it off by putting a 2 there. If that is the case, I've got 2 OHs as well. 2 OHs, or 1 O is there, and then the remaining H's and O's are here. Now, if that is the case, we can go to the next one, which is hot and dilute. So hot and dilute sodium hydroxide. So we've still got sodium hydroxide, we're still adding chlorine, but this time it's hot and dilute. The last one was cold. So if we then take it and we do exactly the same thing and we go, right, okay, let's go this chlorine and let's go all the way over here. Okay, and I will put my numbers in first because I forgot to put my numbers in. Okay, there's 0, there's -1, okay, and there's +5. Okay, so we worked out our oxidation numbers first and then we put it in. So we're going from here to here, that's 0 to -1. 0 to -1 is gaining 1e minus. Okay, and then we go again from this one and we're going to go all the way across here like this. Okay, we're going to go up to that chlorine there. Okay, now that is a bit more dodgy. Okay, so basically that means 0 going to +5. It's lost 5 electrons. So I'm going to write down here, loses 5e minus. Okay, so it loses 5e minus. Now if it lost 5e minus, I need to balance these electrons. Okay, so balance these electrons. Now we've got a bit of a problem. Okay, because know it's lost 5, so think about it. How much of the chlorine do we need, all right, to make those the same? Well, what we're going to need to do is we're going to need to go to this sodium chloride here, and we need to make it so it's 5. Because then that turns the gaining 1 electron into gaining 5 electrons. And now I've got my electrons the same. You see, I've got my electrons the same just by timesing that by 5. I've got my electrons the same. Then I balance everything else. If I look at it, there is 5 chlorines here and another chlorine here, that's 6. And then I have my chlorine here, so that means I've got 6 chlorines on the one side, 6 chlorines on the other side. I know I've got 5 sodiums, 6 sodiums. Okay, so I've got sodium hydroxide here, so I've got 6 here, so I need to put 6 in there. Then I look at it and go, right, okay, 6 hydrogens. 6 hydrogens, go over here. Okay, I've got 2 hydrogens, which means I need to put a 3 here. Let's make that a little bit clearer, sorry. Okay, that wasn't very clear. Let's go whoop, there. There's your 3. Okay, so basically just take the oxidation numbers, find out what's changing, balance the electrons, and then balance everything off. That. We then take it to the next one, okay, and this one appeared in an exam at some point, okay, and this is very similar to this, all right? So if I then go and I go across, I can see from the bromine here, this bromine is +5. Okay, so that's +5. I go across to this bromine, that bromine is -1. I go to this bromine, it's an element, so it's 0. So then from this point, I'm going from +5 to 0, okay? +5 to 0. It's like the opposite of what I'm doing up here. Okay, +5 to 0 means I am losing 5 electrons. Here, I am gaining 5 electrons. My apologies. So I'm gaining 5 electrons to go from +5 to 0. So +5 to 0 gains 5 electrons. The -1, okay, is losing 1 electron. So that means I need to make them the same. Remember, I'm not going to write this down on this one now. I'm just going to say it. So therefore, if you go down here, you are gaining 5 electrons. If you go here, you are losing 1 electron. Okay, so if that is the case, what do I need to times this by? Because I need this to lose 5 electrons and this to gain. So if that's the case, all I have to do is put a 5 here. I've got my 5 here. That means 5 electrons are gained and 5 electrons are lost. Then I can balance everything else. Okay, so if that is the case, I've got 3 oxygens here and I go down to this water, and that means I can just put a 3 by the water. Okay, oxygens are now balanced. Then I can look at the hydrogens. I know there's 6 hydrogens, so I need to go here and I need to write the number 6. Okay, so 3 times 2 is 6, and then 6 there. And then I balance my bromines. My bromines are 1, 2, 3, 4, 5, 6. Okay, so therefore it's 3 Br2 because there's 2 in there. And that's how you balance a redox equation. And we'll do one more just to see if you're good. Okay, remember you can do this yourself. You don't need to wait for me. Okay, and we look at this one. And we do it again, same thing. So I'm going to go put 0, and I'm going to go along here, and that's +1. Okay, you can label all of them. This is -2. Okay, this is +1. Okay, and then this is a bit of a weird one. Remember 1, 2, 3. So 1, 2, 3 for hot. So that's set. Hot, cool. So the oxygen comes before that. Okay. So if the oxygen comes before the chlorine, so let me just write this out. Because this 1, 2, 3 for hot, cool. Okay. So basically, we've got the fluorine not in there. Hydrogen is in there. So that's going to be set. Then the oxygen's in there. So that's going to be set. So that's going to be -2. Which means the chlorine must come off the other 2. Which means if that's -2, the chlorine must be +1. Okay, if that's the case as well, this is +1, and then this is -1. So basically on all of ours, we can see, I'm going to rub it out now, The ones that are changing is 0 to -1 and 0 to +1. Let's get rid of all of these, okay, if we can. Okay, there we go. Okay, and then let's get rid of this on the side as well, because we don't need the hydrogen and we don't need the oxygen. Okay. Okay. Not perfect, but that will do. Okay, so we've got that. So that means that is losing an electron, that is gaining an electron. So this is an easy one, okay? So basically, that means that is balanced. Now, if that's the case, we then balance everything else out. H2O. Oh, it's balanced already. Okay, so basically that's quite a simple one. But the same process. Now, what you can do is if you get another way of doing it, which I'm not going to show here because I think it's a worse way of doing it, and but you can if you want, is you can split your equation into half equations, then balance the half equations, and then put them back together. This is better, so I don't do it. So I hope that explains to you how to balance redox equations.